Welcome back, teachers and educators. My name is Hilary Romer. I am a geoscientist and educator working with the Saskatchewan Mining Association's Outreach Program. In the previous video in this series, we explored some of the introductory lessons that accompany the potash kit. Potash, what is it? Is there potash under my feet? And as well as the Healing Waters of Manitou activity. Remember, these curriculum-correlated lesson plans can be downloaded from the SMA website, and they're also included in the potash kit that is provided free to educators. Curriculum correlations for all these lessons can be found on the SMA website. In today's video, we'll be exploring the first lesson in the potash solution mining series called Dissolving Potash. Let's first review some materials you will need. You will need a potash kit, the teacher samples, student samples, and granular potash. The teacher sample and granular potash will be used for demonstration purposes during the lesson. The student samples will be consumed during the experiment since they will dissolve in water. One kit will serve one class of approximately 30 students. You'll also need 2 clear containers per group. So 500 milliliter beakers or mason jars work well for this. You could also use see-through plastic cups if you are concerned about using glass during the experiment. Students will place their potash sample within the container, and then they'll add 250 milliliters of water. So you will need 250 milliliters of water at room temperature to dissolve the potash, and you can measure it out using a measuring cup or a graduated cylinder. You will also need a coffee filter paper and a funnel. You can make homemade funnels using the tops of bottles, and these will be used to separate the clay and iron minerals from the solution of dissolved salts. Optional materials include a scale to weigh the potash samples, filter paper, and undissolved solids. The weights can be used for older learners so they can calculate the percentage of salt minerals versus insoluble minerals. You can also use a spoon or a stir stick to mix the mixture before filtering to break up any clumps. You can also use timers to keep track of when learners are to draw and record observations. You may also use magnifying glasses, hand lens, or any other materials for identifying and testing minerals. I recommend beginning this lesson by having the students recall what they learned about potash during the introductory lessons. Review that around 380 million years ago, there was a large saltwater sea covering Saskatchewan. At that time, Saskatchewan was located in the tropics, and coral reefs were growing. Due to the growth of the coral reefs and the way the land was shaped, the water became trapped or restricted. The hot climate caused the restricted water to evaporate, resulting in the growth of the salt minerals, which settled on the bottom of the sea. The layers of the salt minerals form the prairie evaporite unit, where Saskatchewan's potash is found today. Also review the 2 different methods of potash mining they learnt about during the introductory lessons. Listen to their responses. If you did not do this in the first lesson, this might be a good time to show a video about potash solution mining. More background information is included in the lesson plans. The largest potash solution mine in the world is in Saskatchewan. Solution mining involves dissolving the potash underground when it is more than 1.5 kilometers deep. Students can examine their sample of potash ore and make observations, or you can pass around your teacher sample. Discuss that potash is a rock made up of the minerals sylvite, KCl, halite, NaCl, which is table salt, clay, and iron minerals. Ask students what mineral they think mining companies want the most of. Listen to their responses. Explain that mining companies' target mineral is sylvite for fertilizer. They also use halite for table salt. Then tell students that they are going to become the solution mining company's chemist. As a chemist, you have to come up with the best way to separate the valuable minerals that those from those that are not. You need to plan a way to separate the clays and iron oxides from the salt minerals. Have groups brainstorm and share their ideas with the class. Explain that during this experiment, they will dissolve the salts using water and then separate the clay and iron minerals by using a filter. Learners will then work in groups as chemists, following the procedures for the experiment while working through the worksheets. The worksheets are easily adaptable to fit with your class. The first step is to examine the potash sample and write down their observations in the chart. If learners are familiar with mineral identification, they can do this within their groups or it can be teacher guided. Remember that the salts will be white or colorless, the clay will be gray, and the iron minerals will be red. Remind students to include labels on their drawings. Students can weigh the samples on the scale and include the result in their observations chart. Then, learners will follow the procedures to set up their experiment. They will follow along with their worksheets for when to record and draw observations. As they're waiting in between times, they can begin answering the discussion questions. Important observations. Bubbles along with white and red particles rise to the top. The red particles could be rising and sinking, and a reddish layer will eventually form. The red flakes might accumulate on the surface. Observing near the surface of the potash, learners may notice waves or small eddies form as the salt along the edges of the ore dissolves. The ore will look rougher because the smooth parts dissolve faster. The clear salt minerals will dissolve into the solution. The next day, there could be air bubbles attached to the side of the container, some red flakes floating on the surface, some suspended in the clear salty solution, no more reddish liquid zone near the bottom, but instead there will be a layer of red and gray sediment at the bottom. At the beginning of next class, have learners record and draw their observations before moving it. Then they can proceed. During this class, learners will separate the clays and iron oxides out by filtering the mixture through a coffee filter and funnel. If learners do not have much clay and iron minerals in their filter, then that means they have a higher grade sample. Learners will continue to work through the procedures and worksheets. The filters will need to be left out to dry. Also, learners will have to weigh a clean dry filter and later their own filters once the clay and iron minerals are dried out, if they are calculating the amount of dissolved salt minerals versus insoluble minerals. A quick recap for today's video. During the dissolving potash lesson, learners acted as chemists at a mining company. They learned that potash is a mixture of salts, clays, and iron oxide minerals. They then explored how to separate out the desired minerals by making a solution of dissolved salts and using a filter to remove the insoluble materials. Important. If you plan to continue with the next lesson, you need to save the salt solution that you just made. In our next video, we'll be exploring the next two lessons in the potash solution mining series called Recovering Dissolved Potash and How Do We Know It's KCl. Learners will be using the salt solution from this experiment and will be exploring how mining companies separate KCl from NaCl. Remember to check out the many free resources that we have at the Saskatchewan Mining Association's website, and if you have any questions, be sure to email us at education@saskmining.ca. Until next time, on behalf of the Saskatchewan Mining Association, thank you for watching. Remember, always stay curious, ask questions, and most importantly, never stop exploring. Bye.